All right, so let's go through paper 2, which is the multiple choice extended option for chemistry. This is Cambridge IGCSE from Cambridge International Examinations, that's CIE, from October-November 2018, and this is variant 1, so 0620/21 is the code. Okay, let's go.
You ready? No. Yes, look good.
Question 1. When smoke particles are observed with a microscope, they are seen to move around randomly. This is called Brownian motion. What causes Brownian motion? All right, so is it the diffusion of smoke particles, molecules in the air hitting the smoke particles, a sublimation of smoke particles, or the smoke particles hitting the walls of the container? Okay, so Brownian motion can happen even if there's no container, so it's not D. Sublimation of smoke particles, well, it happens pretty much at any temperature other than absolute zero, so no, it's not sublimation. And molecules in the air hitting smoke particles. That sounds like a good option because smoke particles are the things you can see, but there's other molecules in the air like oxygen and nitrogen and carbon dioxide and things like that. So that looks like a good answer. And diffusion of the smoke particles, there doesn't have to be a concentration gradient to have Brownian motion, so it's not that. So the answer for this question is B. Question 2. The diagram shows 4 pieces of laboratory equipment. We have a balance and a pipette and a stop clock and a thermometer. Which equipment is essential to find out if dissolving a salt in water is an exothermic process? Okay, well, you can measure out the amount of salt, but it doesn't really matter how much. You want to know whether the temperature goes up or goes down or doesn't change. So it doesn't really matter how much you use. Again, with the pipette, it doesn't matter how much of the water you use. So the pipette isn't really important. Stop clock, you just want to know whether the temperature goes up, not the time it takes. So that means the thermometer is the only thing that is essential to find out if dissolving a salt in water is an exothermic process. So that means the answer to this question is A. So it's not a balance, a pipette, a stop clock, but a thermometer is essential. Question 3. Iodine, I, has a lower relative atomic mass than tellurium, Te, but is placed after it in the periodic table. Which statement explains why iodine is placed after tellurium in the periodic table? So the options we have are iodine has fewer neutrons than tellurium, iodine has fewer protons than tellurium, iodine has more neutrons than tellurium, and then iodine has more protons than tellurium. Okay, so remember, the periodic table is arranged in order of proton number. That means that there has to be one more proton in iodine than there is in tellurium. The neutrons, the number of neutrons, that determines the mass, but it does not determine where it is on the periodic table. So the question is asking why iodine is placed after tellurium in the periodic table. So that means it has nothing to do with neutrons. So these two with neutrons, nothing to do with it. They just happen to be either more or less. It doesn't matter it doesn't make a difference for where they are on the periodic table. Iodine has fewer protons than tellurium. Well, we know that's not true because iodine is after tellurium. Iodine has more protons than tellurium. It has one more proton than tellurium because it's the next atom over. Question 4. Which statement about the isotopes of an element is correct? So we're talking about isotopes. And isotopes, remember, they have the same number of protons and they have different numbers of neutrons. There we go. All right, so same number of protons, different numbers of neutrons. So the physical properties are different because they have different proton numbers. No, that's not correct. If they had different proton numbers, that'd be a different element. So that wouldn't be right. Their atomic masses are different because they have different numbers of electron shells. Well, no, they'll have the same number of electron shells because they are the same element, just different isotopes of it. They have the same chemical properties because they have the same number of electrons in the outer shells. Yes, chemical properties are determined by the electrons, not the number of protons or neutrons. So that sounds like a good answer. And they have the same physical properties because they have the same number of neutrons in their nuclei. Well, they clearly have a different number of neutrons in the nuclei, which means that they'll weigh different amounts. So their physical properties can be slightly different. So the answer is C. Question 5. Which two molecules contain the same number of electrons? Okay, so for the number of electrons, we need to look to see how many protons there are in the uncharged atom, because there'll be the same number of electrons in each. All right, so let's look at the periodic table. Okay, so we're looking at chlorine first. So chlorine is here, and it has 17 protons, which means chlorine has 17 electrons. So that means Cl2 has 17 times 2, which is 34 electrons. Now we're going to look for SO2. SO2, so S has 16 protons, so 16 electrons, and O has 8 protons, so 8 electrons. So SO2 has 16 plus 2 times 8, so 16, which equals 32 electrons. So SO2 has 32 electrons. All right, now we're looking for CH4 and H2O. Okay, so C, carbon, has 6 electrons, and so CH4, H has 1 electron. So CH4 has carbon at 6 plus 4 times 1 is 4, so that equals 10 electrons. Okay, and then we're looking at water. So we already know that H is 1, so we have 2 H's, so we have 2, plus we already know that oxygen has 8, so that equals 10 electrons. Okay, so CH4 has 10 electrons, and H2O has 10 electrons. Ooh, that looks like it's the same number. We'll just double check to make sure we didn't make some sort of mistake. So we'll do carbon monoxide, CO, and NH3. So CO and NH3, what is that? As we know, carbon has 6, O has 8. So CO has 6 plus 8, which equals 14 electrons. And N, which is right here, has 7. So it's NH3 has 7 plus 3 H's, so 3, that's 10. So that's clearly not the same. So CO has 14 and NH3 has 10. Okay, and finally we have CO2 and we have HCl. Well, we know that carbon has 12 and oxygen has 8, so 12 plus 16, 12 plus 8 plus 8 equals 22 electrons. And Cl, we already found out, has 17 up here, so 17 plus 1, that equals 18 electrons. So the only one that has the same number in both of the atoms, both of the molecules, is B. All right. Question 6. Which statement describes the lattice structure of a metal? So be careful. When you see lattice, you often think of as salt, but this is of a metal. So the structure of metal, basically. So the lattice consists of alternating positive and negative ions. That is a salt. All right, so it's not that one because we're talking about a metal. The lattice consists of neutral atoms arranged in layers. No, that's not the answer. The lattice consists of positive ions and a sea of electrons. That is definitely the answer. So C is not neutral atoms and a sea of electrons. So you have your positive and you have your positive ions, and then you have some floating around negatives, which is why it's able to conduct electricity. There we go. Question 7. Which gas sample contains the most molecules? Okay, so a few calculations here. So 24 decimeters cubed of carbon dioxide. So we need to figure out how many moles. So there are 24 decimeters cubed in every mole of carbon dioxide. So that means if you have 24 decimeters cubed of carbon dioxide, you have 1 mole because this is a gas. All right, and 4 grams of hydrogen, H2. So the calculation for this, we have moles equals mass over relative molecular mass. So we have 4 grams over relative molecular mass of hydrogen. Each hydrogen is 1 grams per mole, so 2 grams per mole because it's H2. So 4 divided by 2 equals 2 moles. Okay, so this is 2 moles. Okay, C, 36 decimeters cubed of hydrogen chloride. It's not hydrochloric acid, which would be liquid. Hydrogen chloride is hydrogen chloride gas. Okay, so that is, we have 36 decimeters cubed divided by 24 decimeters cubed per mole, which means that you have 1.5 moles of gas there. So that's 1.5 moles. So far B is winning. It has the most gas molecules, or most molecules. And let's try D. Okay, D again, the formula for this is moles equals mass over relative molecular mass, which equals 14 grams divided by N2. Nitrogen is 14, so that is 28 grams per mole, which means 14 divided by 28, that's 0.5 moles. We have 0.5 moles. So that means the one with the most molecules, because obviously there's 6.02 times 10 to the 23 atoms for every mole, is B. There we go. Question 8. A student mixed together 25 centimeters cubed of 1 mole per decimeter cubed hydrochloric acid and 25 grams of calcium carbonate. Okay, the equation is down below. And what is the maximum volume of carbon dioxide gas that can be collected at room temperature and pressure? Okay, this is one that's probably easiest to do if you write on a separate section. Don't just try to scribble on the sides like what I normally do. Okay, so find a blank page and rewrite the equation. So we have 2 HCl, and that's aqueous, plus CaCO3, and that's a gas, produces CaCl2, and that's aqueous, plus H2O, that's a liquid, plus CO2, which is a gas. We're not interested in everything. We're interested in the hydrochloric acid, calcium carbonate, and carbon dioxide. So we have a 2 to 1 to, well, we can include these, to 1 to 1 to 1 ratio. Okay, so for every 2 moles of hydrochloric acid, you're going to produce 1 mole of carbon dioxide. For every 1 mole of calcium carbonate, you're going to produce 1 mole of carbon dioxide. Now we have to figure out which one of these, the hydrochloric acid or the calcium carbonate, is a limiting reagent. Okay, so first of all, I'm going to figure out how many moles of hydrochloric acid and calcium carbonate we have. So for the moles of a liquid, we have a calculation of concentration times volume. That's how you figure out how many moles are in the liquid. Okay, so we have 1 mole per decimeter cubed, 1.00 mole per decimeter cubed, times, we have 25 centimeters cubed. So 25 centimeters cubed equals 0.025 decimeters cubed, because obviously you have to work in the same units. So 0.025 decimeters cubed. You divide by 1,000. Okay, so that means that the answer is obviously 0.025 moles. So you have 0.025 moles of hydrochloric acid. Now we need the calcium carbonate. So this is a solid, so moles equals mass over relative molecular mass, which is, we have 25.0 grams, 25 grams, divided by the molecular mass of calcium carbonate. Calcium, that is 40 grams per mole. plus carbon, that's 12 grams per mole, plus 3 times oxygen, which is 3 times 16 grams per mole. So that is 25 grams divided by 100 grams per mole, which equals 0.25 moles. So obviously you have fewer moles of hydrochloric acid, and it's a 2-to-1 ratio, so that means the hydrochloric acid is the limiting reagent. Okay, so that's the one you look at. You don't actually even have to look at the calcium carbonate anymore. Okay, so for every 2 moles of hydrochloric acid, you produce 1 mole of carbon dioxide. So every so if we look at moles, so every 0.025 moles of hydrochloric acid, you have to divide that by 2, you produce 0.0125 moles of carbon dioxide. So that's how many moles. Now you need to figure out the volume. Now this is a gas, so the volume equals the moles times 24 decimeter cubed per mole. Okay, and so that is 0.0125 times 24. So the answer is 0.300 decimeters cubed. All right, is that one of the answers? And yes, 0.300 decimeters cubed. Okay, which is 300 centimeters cubed, but this is 300 decimeters cubed, so it's clearly not A. And now in your exam, once you've done all this writing out, what you do, draw a line through it so the examiner doesn't try to mark it. That's just good practice. I don't think they'd mark it on a multiple choice exam, but it's good practice for any exam for CIE. Question 9. Iron can react with sulfur to form 2 ionic compounds. So iron is present as Fe2 plus in one compound and Fe3 plus in the other compound. And sulfur is present as S2 plus in both compounds. What are the formula of the 2 compounds? Now remember, you basically, when you have, so FeS is the first example down here. When you have FeS, basically whatever number is down here and down here, you swap to put the charge. Okay, so you know it says S2 minus in both compounds. So both of them will be S2 minus. So if they're the same, that means that this is Fe2 plus and S2 minus. Okay, and if so, you just swap them. Okay, so here if we're looking at this one, we have Fe3 plus and S2 minus, because you just swap them. Here on this side, you have Fe2 plus because that's from the S, and S2 minus, again, same thing. And you have Fe2 plus and S3 plus. Okay, so those are the 2 sets of ions you get from that one. From C, you have Fe2 plus and S minus. That doesn't make sense. Or it could be Fe4 plus and S2 minus. So you don't get Fe4 plus. Okay, so that can't be it. And those 2 are the same, so it can't be those ones. All right, so if we look at these ones, it says iron is present as Fe2 plus in one compound. So this is the, sorry, I put it way too far away. I'm sorry about that. So we put Fe2 plus in the first one, and the second one has Fe3 plus. Well, that sounds like a good answer. And S is at 2 minus for both of them. That looks like a good answer because this one has Fe2 plus for both of them, and S is 3 plus in the second one, so it's not B. So it looks like the answer for this one is A. In question 10, aqueous copper 2 sulfate is electrolyzed using carbon electrodes. So that means unreactive. Okay, so you're not having any reaction from the electrodes. What is the product at each electrode? Okay, so we have our cell, we have our electrodes, we have one positive, one minus, doesn't matter which one's which, And in our solution, we have copper 2 sulfate, so Cu2 plus, SO4 2 minus, and it's aqueous, so we have some H plus and some OH minus. Okay, so the pluses will go to the minus, plus goes to the minus, and then minuses go to the plus. Minuses go to the plus. Opposites attract. The product at the positive electrode. You can't get copper at the positive electrode because copper is positive and positive does not get attracted to positive. So no, again, the same thing with hydrogen. Hydrogen is positive, it won't go towards the positive. So it looks like you get oxygen at the positive electrode. Okay, so now do you get copper at the negative electrode or do you get hydrogen at the negative electrode? Okay, well, when you're looking at this, you always look at which one, if is copper more reactive or less reactive than hydrogen. If copper is less reactive, then it will be going to it'll be coating the electrode. It'll be the one coming out of solution and going to the electrode and settling down to the bottom. Okay. All right, so the answer here is C. Hydrogen is more reactive than copper, so it's not going to be coming out of solution. Question 11. The diagram shows a circuit used to electrolyze aqueous copper 2 sulfate. Okay, which row indicates the movement of the copper ions in the electrolyte and of the electrons in the external circuit? Okay, so copper ions are positive, Cu2 plus, so the positive is going to go towards the negative. Okay, so that is going to be Cu2 plus going towards the negative electrode. Okay. Okay, so that means that it's either C or D. All right, so now we're looking at the electrons. Well, the electrons are obviously moving towards the positive, so the electrons can move. So the positive, it'll come this way, come up, come around, come like that. The electrons are not going to be attracted to the negative. They're going to be attracted to the positive. And they travel around the circuit in order to make this into a negative. Okay, so that means that they are at 3, so the answer is C. Question 12. Methane burns in an excess of oxygen. The equation is shown, okay? And we have the bond energies are shown in the table. So what is the energy change for the reaction? Okay, so to do this, first of all, we have to look at the bonds broken and then the bonds formed. Okay, so the bonds that are broken, we have CH4, so we have 4 times CH bonds, and thus that equals 4 times CH is 410 kilojoules per mole, which means that's 1640 kilojoules per mole. Okay, we also have 2 oxygen molecules broken apart, so we have 2 times O double bond O. Okay, and so the answer for that is, that's 2 times 496, which equals 992 kilojoules per mole. If you add up 1640 plus 992, that means you get 2,632 kilojoules per mole broken. Okay, now let's look at the bonds formed. Okay, so we've formed, so we have our carbon dioxide, so we have 2 times C double bond O. So that equals 2 times 805 kilojoules per mole. So that is 1610 kilojoules per mole. And we also have 4 OH bonds. 4 times OH, because we have 2 water molecules formed. Okay, so the 4 times OH, that's 4 times 460, which equals 1840 kilojoules per mole. Add 1610 plus 1840, and we have 3450 kilojoules per mole formed, of energy formed. Okay, so the total energy equals bonds broken minus the bonds formed which equals 2632 minus 3450 kilojoules per mole. So that equals negative 818 kilojoules per mole. So the answer is D. All right. So for these questions, go through a nice logical way like this, and you should get the right answer every time. Question 13. The equation for the formation of ammonia is shown. Okay, so the energy level diagram in the reaction is shown. So we start off, we have N2 plus 3H2. We take a certain amount of activation energy, and then there is energy released, and we need to find what is the energy change for this reaction. Okay, so basically we have to take the energy that we started off with, and the energy change is this bit here. So in order to figure out this, okay, so that is 250 kilojoules per mole minus 342 kilojoules per mole. So that is negative 92 kilojoules per mole. And you have to include the negative. That's very important because that means it's lost energy to the surroundings. Okay, so B is negative 92 kilojoules per mole. Question 14. The effects of a change in conditions on a chemical reaction are listed. So we have the total number of collisions per minute are increased. Okay, that can happen in a few ways. That could be the concentration has increased. It could mean that there is a temperature increase. It's unlikely to be addition of a catalyst. Okay. So the number of effective collisions per minute increased. Number of effective collisions, that could be because, the concentration has increased. There's more things there to collide, more crowded. Or the temperature is increased because they're effective collisions. They have enough energy to collide. Okay, so the average energy of the particles increased. That's pretty much just the temperature has increased. Okay, so which change in conditions causes all of these effects? Addition of a catalyst? No, that, so the number of effective collisions per minute, that could also be the catalyst. Okay, so it's not that because it needs to be in all three of those. Increasing the concentration of a solution has nothing to do with the average energy for number 3. Increasing the surface area of a solid reactants, that doesn't really do any of these. Well, it does. It would be the same as increasing the total number of collisions. Possibly increasing the effective number of collisions, but not the average energy. And increasing the temperature, that is changed in all of these. All right. Question 15. When BiCl3 reacts with water, a white precipitate of BiOCl is formed. The equation for the reaction is shown. Which statements are correct? The reaction is reversible. So that has that symbol, which means it's reversible. When dilute hydrochloric acid is added to the reaction mixture, more of the white precipitate forms. So if we add more of this, the reaction will actually progress backwards, which means there'll be less of the white precipitate form. So that's not an answer. When aqueous sodium hydroxide is added to the reaction mixture, more of the white precipitate formed. Okay, so sodium hydroxide is none of these reactants or products. However, sodium hydroxide is an alkali, and when you react an acid and an alkali, you get salt plus water. So this is hydrochloric acid. So this is acid plus alkali produces the salt plus the water, which means basically it's taking the chloride ions out of solution. So if it's taking the chloride ions out of solution, that means that the reaction is going to move to the right-hand side, and more of the precipitate is going to form. So that means that is a correct answer. So the answer is 1 and 3 only. Question 16. An excess of iron 2 chloride is added to acidified potassium permanganate, potassium manganate 7. Which statements are correct? Okay. So let's start from the bottom. So potassium manganate is an oxidizing agent. It has a lot of oxygen in it. KMnO4. It's an oxidizing agent. It definitely causes oxidation in other reactants. So it's definitely an oxidizing agent. So the manganate ions are oxidized to manganese ions. They're not oxidized. You don't add more oxygen to potassium manganate. It's pretty much as oxygenated as it gets. So iron 2 is reduced to iron 3. No, it's not. No, it's not. And the purple color disappears? Well, yes, because when it oxidizes a reactant, the purple color disappears. So the answer here is 1 and 4. Question 17. Part of the periodic table is shown. Which element forms an oxide that reacts with dilute acid to form a salt and water? So obviously, it's talking about a basic oxide. Okay, so which element has a basic oxide? Okay, and if we look at this, they're the alkali metals and alkali earth metals, which leads to the conclusion that they're alkali. They form basic oxides. So that means the answer is C. Question 18. Aqueous sodium hydroxide is added to solid Q in a test tube. A gas is produced which turns damp red litmus blue. Okay, so basically it has to be alkaline, and the test that's often used with this is generally that's for ammonia gas. Just an alkaline gas, which is generally ammonia gas. Okay, so what is Q? So if you mix sodium hydroxide with aluminium, do you get ammonia gas? Nope. And sodium hydroxide with ammonia gas? No, ammonia is the product, not the reactant. Sodium hydroxide with ammonium chloride? Yep, that makes sense. You'll get ammonia gas. And then sodium hydroxide with sodium nitrate? No reason to get ammonia gas there, so the answer is C. Question 19. Potassium hydroxide is a base. Which statement describes a reaction of potassium hydroxide? Okay. A. Chlorine is formed when it is heated with ammonium chloride. All right, so if you reheat ammonium chloride and potassium hydroxide, you'll get ammonia gas, just like in the previous question with sodium hydroxide. You'll also get potassium chloride and water. You won't get chlorine gas. You'll get ammonia gas instead. It turns universal indicator green, so that would be a neutral. Green is neutral. So if you react a base with a base, you're not going to get neutral, so that doesn't make sense. It reacts with an acid to produce a salt and water. Well, potassium is a base, an acid plus a base produces salt and water. That's one of those reactions that you really need to know, so yes. And it turns methyl orange red. Well, methyl orange, when it's in an acid, it turns pink. And when it's in an alkali, it is yellow. So, no, it's not going to turn it red for any reason. The answer is C. Question 20. Some general rules for the solubility of salts in water are listed. Okay, these are things you should probably make sure you know anyway. It helps. Carbonates are insoluble, except ammonium carbonate, potassium carbonate, and sodium carbonate. Okay, those ones are soluble. Chlorides are soluble, except lead-2 chloride and silver chloride. And nitrates are soluble, well, pretty much all of them. And sulfates are soluble, except barium sulfate, calcium sulfate, and lead-2 sulfate. Okay, so which substances produce an insoluble salt when aqueous solutions of them are mixed? Okay, so with these, we'll just assume that everything reacts. So barium chloride reacts with magnesium nitrate. We will get barium nitrate and magnesium chloride. Okay, so I'm going to cross out anything that is soluble because it's looking for an insoluble salt, trying to figure out which one's an insoluble salt. Okay, so nitrates. It says nitrates are soluble, so that is not one of the ones you're looking for. Magnesium chloride. Chlorides are soluble except lead-2 chloride and silver chloride. Well, it's not that one. Okay, so let's try the next one. Calcium chloride and ammonium nitrate produce calcium nitrate, just swapping them, plus ammonium chloride. Okay, so nitrates are soluble, as it says in point 3. And chlorides, in point 2, it says chlorides are soluble except lead-2 chloride and silver chloride. And ammonium chloride is not one of those two. Okay, C. Silver nitrate and zinc chloride. Okay, it will produce silver chloride plus zinc nitrate. All right, so silver chloride. Chlorides are soluble except lead 2 chloride and silver chloride. Ooh, that looks like it's the one that we want. It's an insoluble salt. And zinc nitrate, nitrates are soluble, so that's not one. So we're looking for something with one insoluble salt. It looks like the answer is C. Let's just check with D just to make sure. So sodium carbonate plus potassium sulfate, that will produce sodium sulfate and potassium carbonate. These are all double displacement reactions. Okay, so sodium sulfate. Let's look at the sulfates. The sulfates are soluble, except barium sulfate, calcium sulfate, and lead 2 sulfate, so that means it's an insoluble. No, it's a soluble salt. And potassium carbonate. Carbonates are insoluble, okay, except ammonium carbonate, potassium carbonate. Okay, so we have potassium carbonate soluble, so that's not an insoluble salt either. So the answer here is C. There we go. Question 21. Elements in group 1 of the periodic table react with water. Which row describes the products made in the reaction and the trend in reactivity of the elements? All right, so let's look at group 1. So the elements in group 1, that includes hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. And you should remember that the reactivity increases as you go down the group. Okay, so francium is ridiculously reactive. You will not have that ever in a science class, and you do the squeaky pop reaction all the time in your chemistry class, I'm sure. So now we're going to look at the reaction with water. Okay, let's take sodium for instance. Sodium, when you react sodium with water, you get sodium hydroxide, NaOH, plus hydrogen for the squeaky pop. Okay, so that would mean that the products are metal hydroxide, the sodium hydroxide and hydrogen. You don't get sodium oxide. And it becomes more reactive down the group. So the answer is B. Question 22. The equation shows the reaction between a halogen and aqueous bromide ions. Okay, which words complete the gaps 1, 2, and 3? Okay, so this is a halogen, the X is a halogen, and the bromide ion. So we need something. If this is going to be a reaction, that means that X has to be more reactive than bromine. Okay, so if we look at the halogens, we have chlorine, Cl2, we have bromine, Br2, we have iodine, I2. Chlorine is more reactive than bromine, which is more reactive than iodine. That means that X has to be chlorine. It's not iodine, because iodine is less reactive. It's not going to be able to kick the bromine out of the way to go with whatever partner the bromine is with. All right, so chlorine is in the first spot. What color is bromide ions? Bromine in solution as ions, they're colorless. But when you get bromine gas, it's a brown color, a yellowy brown color. So the answer is B. Question 23. An inert gas R is used to fill weather balloons. So inert gases, what we generally mean is a noble gas. That's generally what we mean by inert gas. And using to fill weather balloons, well, it has to be a very, very light gas. Okay, so very, very light gases, well, that's helium. Hydrogen is a very light gas, but hydrogen is not inert. Hydrogen combusts and does react, so it's not an inert gas. So I'd say it's not hydrogen. So which descriptions of R are correct? So I'd say it has to be helium. So is helium, how many electrons does it have in the outer shell? It has 2. It doesn't have 8. Is it a diatomic molecule or a single atom? Helium is a single atom. It's B. Now, the reason why it's not the other noble gases is because they're much heavier. Helium is used instead of hydrogen because it doesn't react. So helium is a choice that they would use. Question 24. A student heated copper 2 carbonate and copper 2 nitrate in separate test tubes. Both compounds decomposed. Which row shows the gases produced from each reaction? Well, carbonates, if carbonates decompose, they produce carbon dioxide. That's why 3 out of the 4 of the answers are carbon dioxide. It probably is the right one. And it is. Okay, and copper 2 nitrate. Now, copper 2 nitrate, that's CuNO3 2. And if you look at that, there's quite a lot of oxygen. So is it nitrogen dioxide only? No. Nitrogen and oxygen only? Is it oxygen only? No. And oxygen and nitrogen dioxide, yes, because nitrogen is a gas as well. If oxygen decomposes with it, it will also decompose the nitrogen. Copper is much heavier. It's not going to be a gas. Okay, so it'll be oxygen and nitrogen dioxide. So the answer is C. Question 25. Metal X reacts with steam but not with cold water. What is X? Okay, so calcium. Calcium reacts slowly with cold water, and it does react with steam, so it's not A. Copper, well, it doesn't react with either cold water or steam, so it's definitely not B. Sodium, well, that reacts quickly with cold water, and it'll be very, very quick with steam. And zinc, it reacts with steam, but not cold water, so the answer is D. Question 26. Which row shows uses of the metals listed? Okay, so aluminium is used in aircraft manufacture. Yes. Cutlery, not really. Steel is used instead of aluminium. Electrical wiring, nope. Copper is used instead of aluminium. And food containers, yes. So copper is used in food containers. No, that would be excessive. Electrical wiring, yes, it's used all the time in electrical wiring. Aircraft manufacturer, no, that would be really expensive. And cooking utensils, well, when they say cooking utensils, they mean things like the pots and the pans and the things like that. So when you're cooking, you don't want things to react with it. So yes, you can get copper pots, copper pans, and some other copper cooking utensils. Okay, so far it looks like the answer is D, but let's just double check. Mild steel. Okay, cutlery. Yeah, you can have steel cutlery, absolutely. Chemical plants, I believe you can use, they're chemical plants. It's not particularly reactive. Cooking utensils, yeah, they have steel cooking utensils. And car bodies, yes, it's used in car bodies. So the answer is D, because that's the only one that has all of them. Question 27. Aluminium objects do not need protection from corrosion. Iron objects must be protected from corrosion. Why does aluminium resist corrosion? Now this one I find interesting. I just do, because you always think of aluminium as a completely unreactive metal because it is everywhere. You use it in everywhere you don't want reactions, like aluminium foil, aluminium airplanes, aluminium food containers. These you do not want any corrosion. So you think it's unreactive, but the reason why you use them is because it is extremely reactive. It reacts with the oxygen so quickly that there is a protective oxide layer on the aluminium. Okay, so aluminium does not form ions easily? No, that's not why. Aluminium does not react with water or air? Absolutely not. It really reacts with water and air. It just reacts so quickly that there's always going to be a protective oxide layer. And aluminium is below iron in the reactivity series? No, it's very reactive actually. So the answer is C. Question 28. Which statement describes the role of iron in the Haber process? Is it used as a catalyst, as a reducing agent, to condense ammonia gas into a liquid, or to increase the yield of ammonia? Well, iron is a catalyst in the Haber process. All right. Question 29. Which statement about air pollutants is not correct? Carbon monoxide is formed from the complete combustion of petroleum. Complete combustion? No. Carbon monoxide is formed from incomplete combustion. If it were complete combustion, it would be carbon dioxide. So I'd say the answer is A. But let's just check to make sure none of the others are. Lead compounds are formed from some types of petrol. That is absolutely true. They have to actually take the lead out of the petrol to make it safe so that the lead compounds aren't formed. Oxides of nitrogen are formed from the combustion of reactions, from the combustion reactions inside car engines. Absolutely true. And sulfur dioxide is formed from the combustion of coal. Yes, because sulfur is one of the impurities. So the answer is A. Question 30. Argon is a noble gas used to fill light bulbs. What is the approximate percentage of argon in air? Well, there's really not very much argon in air. It's only 1%. There we go. Question 31. The diagrams show experiments involving the rusting of iron. Okay, tube P. We have water with iron nails, well, just open to the air. So in order to have rusting, you need water plus oxygen. And if you have water and oxygen, you're going to get rust. Well, you're likely to get rust. So tube P, that should rust. And a student predicted the following results. In tube P, the iron nail rusts. I would say that's correct. And in tube Q, the water is boiled so that the air is removed. Okay, so that it doesn't have the oxygen or very little oxygen. And there's a layer of oil on top of the boiled water. That prevents new oxygen from dissolving in. Okay, that still makes it so it's not likely to have very much oxygen. And there's even a lid on top so that if there is any air getting in, if there is any oxygen here, it's really not going to get more. So there's water, but there's no oxygen really. So that looks like it's not going to rust. In tube R, the iron nails do not rust. Okay, so tube R, a lid on top to stop other water and oxygen from getting in. That looks like it's going to help. And anhydrous calcium chloride to dry the air. It looks like that one is not going to rust either. So it looks like the student predicted correctly in all three experiments, 1, 2, and 3. Question 32. A diagram of the carbon cycle is shown. Which processes are represented by the letters W, X, and Y? Okay, W, we have carbon dioxide in the air going into plants. That's through the process of photosynthesis. So it's one of those two. Okay, then the plants are eaten by the animals, and animals breathe out carbon dioxide because they've done respiration, not because they've done combustion. That would be kind of silly if we had to burn ourselves to produce carbon dioxide in the air. That doesn't really work. Okay, and then we look down here. Oh, and also plants also do respiration as well. So plants do both respiration and photosynthesis. Okay, and fossil fuels go to carbon dioxide. Now that is through combustion. You have to burn the fossil fuels for them to get into the air. So the answer is B. Question 33. Which statement about sulfur or one of its compounds is correct? So sulfur occurs naturally as the element sulfur. That sounds correct? Yes. Sulfur dioxide is used to kill bacteria in drinking water. No, it's not sulfur dioxide, it's chlorine. Okay, so it's not that. Sulfuric acid is a weak acid. Nope, it's a strong acid. And dilute sulfuric acid is a dehydrating agent. Nope. Concentrated sulfuric acid is a dehydrating agent, but not dilute sulfuric acid. So the answer is A. Question 34. Which reaction is endothermic? So we have calcium carbonate produces calcium oxide plus carbon dioxide. That takes energy to break those bonds. So I would say that one is an endothermic reaction. Okay, calcium oxide plus hydrochloric acid. That is an alkali plus an acid produces a salt in water. That is a neutralization reaction. That's not endothermic. That's not an endothermic reaction. All right, calcium plus oxygen produces calcium oxide. Well, that actually, it releases energy when bonds are formed. So this is not endothermic, that'd be exothermic. And calcium plus hydrochloric acid produces calcium chloride plus hydrogen. No, that's also not an endothermic reaction. The answer is A. Remember, it takes energy to break bonds, and it produces energy when you make bonds. Question 35. Which equation representing a reaction of methane is correct? Okay, so methane plus chlorine gas, Cl2, produces CH3Cl plus HCl. That looks like a good reaction. Let's check the others. CH4, methane, plus chlorine gas produces CH4Cl2. Well, I'm not quite sure how that molecule would look, considering a carbon can only have 4 bonds attached. So it was CH4. Now, where would those Cl2s go? Because hydrogen can only have 1, carbon can only have 4. I'm not convinced I even understand what the molecule would look like, so no. So CH4 plus Cl2, methane plus chlorine, produces CH2Cl2 plus H2. No, that doesn't work. That'd be a much more complicated process than A. And 2 CH4s plus 2 Cl2s produce 2 CH3Cls plus Cl2 plus H2. Now this is a complex equation. There's no reason why they should have chlorine on the reactants and product side, so that they should take that and cross that out, and then that's not a reaction that occurs. So there's no need for that. That's not the answer. The answer is A, which is a nice, simple reaction. Question 36. Which 2 compounds are molecules which both contain a double bond? Okay, so ethane. So remember, your monkeys eat peeled bananas. 1 carbon, 2 carbons, 3 carbons, 4 carbons, methane, ethane, propane, butane. E has 2 carbons. So ethane, there we go, that's ethane. Each of these attaches to an H. So there's no double bond in ethane. Ethanoic acid, this is ethane. Ethanoic acid, again, 2 carbons. OH, H. This is ethanoic acid. So that does have a double bond. So ethane doesn't, so that's crossed off. Ethane doesn't, that doesn't. Ethanol, again, CCOH, H. This is ethanol. There's no double bond in ethanol either. Okay, so ethene has C, H. This is ethene. Yes, there's a double bond in ethene. There's a double bond in ethanoic acid. So the answer should be C. Again, we look at this one, ethene. Yes, there's a double bond here, but there's not an ethanol. So the answer is C. Question 37. Ethanol can be formed by fermentation or reaction between steam and ethene. So which of these processes uses a catalyst? Okay, well, reaction between ethene and steam, yes, that absolutely requires a catalyst. So it's one of those two. Fermentation uses biological catalysts called enzymes, so the answer is A. Question 38. When the alcohol CH3CH2CH2OH reacts with the carboxylic acid CH3CH2CH2COOH, an ester is formed. What is the name and structural formula of this ester? Well, first of all, when you react an alcohol and an acid to produce an ester, the alcohol ends up with the "il" on the end of the name, and the acid has the OH at the end. So we're looking for 1, 2, 3 carbons. So remember, our monkeys eat peeled bananas. 3 carbons, 1, 2, 3. That's the prop. So we're looking at propyl. And this is 1, 2, 3, 4 carbons. And that's the bute. So propyl butanoate would be the answer for that one. Now, which one of these is it? Okay, so let's react to this. We have C, 3 carbons in a row. Okay, these are H's. I'm not going to draw on the H's there. We have I'm going to just do the OH down here. And then we react it with the butanoic acid. Okay, I'm going to draw it the other way around. So we have a C, we have an OH here, a double bond O here, and then we have, it's 1, 2, 3, 4 carbons. So 1, 2, 3, 4. All of these have hydrogens attached to them. Okay, so I put it like this. It's the opposite way to what this is written, but this makes it easier. So you could say, okay, so we take this out and we end up with our ester. Okay, now which way do we draw this from? Well, we draw it so we can write a COOC, whichever way it is. If we write it from this way, CO, there's only one O in between here, and this would be COCO almost, but not quite. You don't really do that. If you draw it from this direction, it was COOC. So it works better because this C is attached to 2 O's, but this C is only attached to 1 O. So let's draw it from the right side to the left. So it produces 1, 2, 3, 4 carbons. Okay, and a double bond O, and an O, and a C, and then we have 3 carbons. There we go. All right, so plus an H2O, plus H2O from that came out. Okay, so which one of that? So that's CH3, CH2, CH2, COO, CH2, CH2, CH3. The answer is D. Question 39. A solution of ethanol and water is left to stand in an open beaker in a warm room for 3 weeks. Which statement explains what happens to the ethanol in the solution? Okay, so the ethanol is dehydrated to ethene. Well, there's no reason for it to be dehydrated because it is mixed with water. So the water would have to completely evaporate first, and then that doesn't make sense. Ethanol would evaporate before the water anyway. So it's not A. Ethanol is hydrolyzed to ethene. So water is broken to become ethene. That actually doesn't make sense. The ethanol is oxidized to ethanoic acid. Well, ethanoic acid contains more oxygen than ethanol, so that makes sense. It's certainly not reduced to ethanoic acid because you can't gain oxygen and have it being reduced. So the answer is C. Question 40. The structure of a polymer is shown. Which monomer is used to make this polymer? Okay, so if we look at this, we have CH2 and C with 2 CH3s off of it, then CH2, then C with 2 H3 off of it. Looks like the monomers are broken off here. Now you always have the double bond for these ones, so those all have double bonds, that makes sense. Now basically what's happened is it used to have a double bond there, the bond was broken, and then it just formed on, it was able to react with something on the side. So it started off with looking exactly the same, but with a double bond in the middle. And that would be D. There we go. And that's the last question on this exam. I hope you found this useful and liked it. If you did, I would really appreciate it if you push the thumbs up button, and if you'd subscribe if you haven't already. If you have anything you'd like to say to us, please write them in the comments below. We really like hearing from you, and have a great day.